So yeah, I have a lot of slides, but and there will be a lot of things which I won't be able to get like the all details about, but the slides will be online and I will be here to talk. So yeah, let's begin. Yeah. So a little bit about myself. My previous workplace was at the Hungarian CCTLD, and now I work for PCH. And DNSSEC is my main job, basically, which I consider a never-ending learning, at least for me. I don't know about you. That's how for me. So I have a few slides about PCH, but I will, because this is a technical talk, I will just quickly shuffle through. If you want, you can look at the slides. You can talk me in the hallways, whatever. So yeah. But this talk is about multi-signer, and before this development, basically TLD operators, sometimes we will work with TLD operators, had like two choices. They either did the DNSSEC signing, yeah, another on my slide, sorry. So they either did their DNSSEC signing themselves, or they asked PCH to help. So we did the signing for them. But now there is maybe like a third option, and actually this is something which we use with PG, which is Papua New Guinea. So this is when we sign the zone. They sign the zone themselves, and we independently sign the zone as well. And this redundancy can help to protect against like operational errors, network issues, whatever. So yeah. I use some colors in my slides, and they have meaning. So this is kind of like consistent during my slides. So yeah, there is the registry, which generates the zone every whatever time it's set to generate. There is one organization doing signing on, which is the COCO signer, and the other one is the PCH signer. They each use a different ZSK. One of them is nominated by green, the other one is yellow. Yep. And this is the multi-signer RFC. So this is what we are talking about. And again, to just keep things simple for ourselves, and this is a quick talk. So DNS key records are in focus for multi-signer and for DNSSEC, of course, but especially for the DNSSEC multi-signer. So the signer keys needs to be published in the DNS key error set to be accepted by validating resolvers. And the scenario which I'm going after, or we are going after now, is a common KSK with a unique ZSK per provider. Right. So let's think about the simple scenario. So this is just like a simple single signer, one provider. If you look at the slide, the T1 is like, they are like different points in time. So at T1 time, we have like one KSK and one ZSK. And when a transition key rollover is happening for the ZSK, you basically have like the three keys listed. And when after the right timing, I mean TTL, so everyone's cache has the new ZSK, they can switch over to new one. So this basically means that there are like 2 or 3 keys in use at a time. And this might look like a lot more complicated, but maybe not if you just think about like the previous slide. If we have like two providers or 2 signers, then you have like 3 keys at a time, or maybe 4 when a roll is happening. And with like the right alignment, this is possible actually. Yeah. The important part is the signers needs to be synchronized in a way that both signers with the right timing publish these keys. Yeah. This is for future reference in the slides, yeah. So not DNS. Not DNS has a capability called manual mode. So basically using CASP, but you manually set the schedule. And there is another one, which is offline KSK mode, which is on top. It is not just timing information for your keys, but also has the DNS key RR set and the RR sig signed in advance. And this basically manipulates or sets the DNS key error set in the process, which is exactly what is needed or can make multi-signer possible, because we need precise control or write control with for the multi-signer. So Not DNS and also Bind has tools or a tool set to help you with that. So there is a command to generate your ZSKs. You can set the schedule in some configuration file. There is also a way to generate signing requests. Then you sign the results and you import that into the signer. Okay. There is tooling in the DNS software to basically hold your hand, and the only missing piece is that we are not talking about one signer, we are talking about multiple signers. So we basically need to merge these requests together. And I made a Perl script which does the job. And this is something which we used. The end result is this, that we have, hopefully it's somewhat visible. Yeah. So we have like one ZSK from one provider, which is published in the DNS key error set. There is another one. One of them is with the yellow color, the other one with the green color, and everything is signed by the KSK. And as you see, all the servers are providing the same RR set with the same signature. And the SOA record, and of course the other records in the zone as well, are signed. And yeah, again, if you think about, this is exactly the same scenario, like if you would have like just a single signer with the rollover, a ZSK rollover going on, but this is like just normal life for this kind of setup. So some servers have signing with one ZSK, so the other one with the other ZSK, which basically means that the RR-sig will be different. Yeah. Is this a not only feature? No. Bind gained the offline KSK functionality in 9.20. So it is also possible to use bind and not. Currently, this setup is using 2 not servers, but we are looking into to do the same setup for one side for diversity with not. Thanks for PG Papua New Guinea for trusting us with this task. Coca is hosting one of the signers. PCH is hosting the other one. And thanks for the software developers who are working hard to make DNSSEC more available and more friendly. Yeah, that's all from me. Any questions? Oh yeah, and one more comment. So the keys are different in this case because there are different like security boundaries. So that's why. If it would be like the same organization, of course, then the keys would be just easily be copied over or something like that, shared in other ways.
So Klaus Aurelian from Nick.at. Tamas, I wonder why actually do you use 2 signers? Because you could only, so you could, on your Anycast name servers, you could use the sign zone after the Cocoa signed the zone, or the other way around. So what's really the benefit of having 2 signers? Of course, if one fails, the other works. But if one is broken and generates like broken signatures, it doesn't help that there's another one, because half of the name servers are providing wrong responses.
Because of the nature of the offline KSK, there is some kind of guarantee. It's not a perfect guarantee, but there is some kind of guarantee that the DNS key error set will be fine. And as long as as that part is fine, it should be fine, because if it doesn't sign, if it is offline, if there is like a power issue going on, or even if there is some kind of issue just with the ZSK, it should be just fine.
But what actually is the benefit of having 2 signers and not using just one?
The perfect scenario would be if the other one would be someone who is learning, so it's a learning opportunity or a setup where they can dig into the setup, they can better understand their side as well, and so it's not just like completely in one hand the signing.
Okay, thanks.
Hi, Arya Khanna, NL Labs. So I wanted to ask about your experience with Not in Bind and trying to set up these multi-signer instances. Were there particular pain points? What was your experience with these two?
So it seems that the offline KSK functionality is something which it's something which which was initially seemed like a complicated concept to me, but after trying it out and after like a few trials, it just went fine. So I'm pretty pleased with the offline KSK functionality, and I did some initial tests with Bind 9 as well, but I have less experience on that side at the moment. But that also seems promising because there were new developments in like the recent 1 or 2 years on that part as well.
Thanks.
Hey, Tamas, this is Shumon from Salesforce. So an observation and then a question. So you didn't point it out clearly in your presentation, but specifically your multi-signer deployment is Model 1, right? Shared
Yes,
KSK
yes.
and multiple ZSKs per provider. So I just wanted to point out this is a less commonly deployed scenario. So it's interesting that you have deployed it. So my question is, why did you choose this model versus Model 2, where each provider has independent KSKs and ZSKs that have to be coordinated?
We chose because in this scenario, it was reasonable to say that there is like a provider who can hold the key, and these two organizations are not too far from each other.
Yep.
So the communication can easily happen, which means that having just one KSK is enough because there are no like two like completely independent organization which would need to like work completely independently of each other. And this is like a coordination point, which also means that the synchronization only need to happen like at one time, or I mean regularly at some interval, but there is no like constant communication going back and forth because of the offline KSK nature. When the signing of this signature is happening, that is when we can call a synchronization point.
Okay, got it. So your answer prompted another observation for me, that the situation is a little bit asymmetric, right? There's one provider which is in control of the KSK. There's two providers, but PCH, I assume from your description, is the one that controls the KSK, right? So if
That's correct, yeah.
PCH were to go down, then you couldn't do any key rollovers in the other provider independently, right? Because you have to re-sign the DNS key RR set, right?
That is correct.
So how do you deal with the second provider when they decide to roll the KSK? Is there any automation that triggers the right thing to happen at the DNS key RR set, or is that
No,
a
so
manual coordination?
basically the keys are saved in a way that if it's needed, it can be accessed, and that can help with future rollovers if that is necessary.
Okay, great. Thank you.
Hello, Stefan Ebbing, SIDN. I was wondering, have you looked at the TCP queries to your nodes? And if so, did you see a difference after you changed to this setup, and what did you see?
You are probably asking this because of the key sizes.
Yes.
Yes. And the answer for that one is that this is using algorithm 15, where the sizes are even smaller than with RSA. So we haven't checked in particular, but I know that the key sizes and in effect the DNS response sizes are generally smaller than with RSA.
So for .nl, we looked at it during our algorithm rollover, and then we had about 5% TCP instead of 1% TCP. So it might be useful to look at this and see if it's a problem or not.
Yeah.
Thank you very much.
So if you look at it, I just displayed that slide. So basically, the byte size is like 300, around 300. So they simply fit the DNS flag day recommendations.
Yes, thank you.
Matthijs Mekking. I see. I actually got up for what Schumann was saying. There's a Model 2 and Model 1, and Model 2 is very nice and very much used because you own your own keys, right? So you can do the signing yourself. But I like Model 1 as well because you basically avoid that once a provider does a key rollover, you have to interact with the other one, and you have to wait until everything's fine, have to see if there's errors. If nothing happens, you don't know what's going on. Basically, with Model 1, you put all that effort up front. So you decide for the next coming year, these are the rollovers for the ZSK. Just sign stuff and import it. And you no longer have to have that interaction. So once you are past that point, you're in a much better, nicer position to do the DNSSEC signing, in my opinion.
I do agree. And for this use case, this was actually a more convenient option for us, both on the offline KSK part, and both that there is just one KSK going on,
Right.
so no more. But I think with simple modifications, multiple KSK, so the other model could be implemented using the same underlying bits or mechanisms.
Right. So I think
in both ISC bind and not DNS.
Yeah. So for operators, I think my observation, maybe I'm wrong, but my observation is if you have a good ownership of the key, like for example, in your example, offline KSK is maybe the best way forward. So just upfront say the rollover, so the next year will happen at this time. It's also then you know what to expect. You don't have the interaction with the other providers anymore. If it's not possible, then for example, for Salesforce and other company might be not possible. And then I understand Model 2 is required.
Yeah. Okay. Thank you.
Thank you, Tamas.